Hey guys, this is going to be the Chapter 11 quiz tips video. We are just going to go through the practice quiz, and if I think of anything that will help you as far as tips and advice for the quiz, I will let you know. So for this first one here, we're just supposed to write sentences that give all of the information, and that might seem daunting, but have faith in yourself, okay? You're going to name everything. You're going to say reacts to form or whatever in the middle, and just make sure that you throw in those physical states somehow. And if there's something over the arrow, you need to include that, address that as well. So for example, on part A, I might write something like solid potassium chlorate. Okay, we do expect you to be able to name this compound. Okay, solid potassium chlorate produces or breaks down to form solid potassium chloride and oxygen gas when it is heated. Okay, or you could say if you heat potassium chlorate solid, it will break down into, or it will form solid potassium chloride and oxygen gas. Okay. All right, this second one, two nonmetals, so that's going to be covalent. So we would want to name that with the covalent system. This is technically hydrogen peroxide, but if you didn't know that, you could say dihydrogen dioxide liquid breaks down into liquid water and oxygen gas using potassium iodide as a catalyst. Okay, if you put Ki as a catalyst, I think that would be okay, but to be really complete, you'd want to name whatever the substance was above the arrow. So again, liquid hydrogen peroxide or liquid dihydrogen dioxide will form liquid water and oxygen gas using potassium iodide as a catalyst. If you need to do two sentences to get all that information, that's fine. We just need to see it all as words. Okay, 2, what is Ki in the reaction in part B above? This is me just saying, make sure you noticed that, okay? It's a catalyst, and that speeds up a reaction, okay? 3, what is a skeleton equation? It's unbalanced, something that has not been balanced. So these right now are both skeleton equations because they haven't been balanced up here, okay? 4, what does a double arrow in a reaction mean? So when we see this double arrow, that means that the reaction can go in both directions, and each direction is a different type of reaction. So going in this direction, we're combining two elements to make a compound. That's synthesis or a combination reaction. The reverse reaction is that compound splitting up, so that's going to be a decomposition reaction. Okay. When you see these questions, there is a line up here that tells you what to do. Every year we get students who don't do all of the pieces, okay? You need to balance, you need to add physical states, and you need to classify, right? That should be pretty obvious since we have these lines over here, but you need to do all of those things, okay? So when you do these, first of all, let's just go through the types of reactions since you've already done your practice quiz here. This one right here, two elements forming one substance after the arrow, that is a combination or a synthesis. Okay. This one, carbon compound plus oxygen, CO2 and water are produced, combustion. That's our combustion of a hydrocarbon, okay? You just write combustion. This one, I've got carbon partnered with hydrogen, chlorine on its own. It's diatomic, but it's on its own, it's just chlorine. Over here, carbon kicked out by itself and hydrogen with chlorine. This is a single replacement reaction. Now, carbon's not on the activity series on our periodic table, but this is a single replacement. Part D, we got one substance breaking apart into multiple. That is a decomposition. And part E, two compounds before the arrow, two different compounds after the arrow. These have traded partners. That is a double replacement reaction. Hydrogen and hydroxide get together to make water. That one's a little harder to see partner-wise, but this is a double replacement. Physical states. All right, here we go. Antimony, Sb, if you look at the periodic table, has a black symbol, so that's a solid. Oxygen has a red symbol, so that's a gas. Again, we're using our periodic tables, our school periodic tables. Compounds by themselves on one side of the arrow are almost always going to be solid. So this one would be our solid. It's also a metal oxide, which makes it solid. C2H2, hydrocarbons that have very small numbers of carbon are going to be gases. So this one, only two carbon atoms, that's a gas. Oxygen's a gas. Carbon dioxide and water are both gases in a combustion reaction because of the high temperature. C10H16, 10 carbons puts it into the liquid category of our hydrocarbons that we took notes on. Chlorine, when we look at the periodic table, its red symbol tells us it's a gas. Carbon is solid, black symbol on the periodic table. And HCl is an acid. So I would hope you put aqueous because acids are aqueous. If you put another physical state here, this one we wouldn't be too critical on because we're hoping that you see that that's an acid and put a gas. But again, some of these you might not necessarily know, and so we're not going to be hypercritical. Part D, barium carbonate by itself, that's a solid. Other side, barium oxide, metal oxide, that's a solid. And CO2 is carbon dioxide. Hopefully we recognize that as a gas. Part E, double replacement. Everything before the arrow is aqueous. Everything before the arrow is aqueous. After the arrow, we're looking for one aqueous. This one has an alkali metal, so this one's aqueous, and we know water's a liquid. Okay? Balancing, part A, you'd have a 4 in front of antimony, a 3 in front of oxygen, and nothing in front of antimony oxide because that would be an implied 1. For part B, 2, 5, 4, 2. 2, 5, 4, 2. So 4 in front of the CO2. Part C, implied 1, so nothing written here. 8 chlorines, 10 carbon atoms, 16 HCls. So 16 in front of HCl. Part D is already balanced. And part E, we end up with a 2 in front of NaOH and a 2 in front of water. So hopefully you're doing well on balancing. Number 6, what does aqueous mean? There's some key letters in this, okay? It means the substance is dissolved, ED, at the end, in water. It is actually dissolved in water. If I have a handful of salt, that is solid. I know salt can dissolve in water, but in my hand, when it's just sitting in my hand, it's solid. When I put it into water and it dissolves, that makes it aqueous. So it has to be dissolved in water. You don't want to write dissolves with an S because things that do dissolve but aren't currently dissolved are not aqueous. I know that this might seem like I'm spending way too much time on this, but you do need to understand that it means it is actually dissolved in water right now if you put AQ next to that substance. Okay, and again, represented with an AQ in parentheses. 7, what is a precipitate? Okay, again, there's lots of ways you could define this. Okay, it's a solid that forms in a double replacement reaction. It's a solid that forms when you mix 2 solutions. It's a solid that forms when you mix 2 aqueous substances. There's lots of ways that you can describe this. You definitely need to tell me it's a solid and something about when and how it forms. Okay, and it's represented in a chemical equation by putting S in parentheses. All right, number 8, you're going to have an option on the net ionic piece. Okay, these are both double replacements that you're supposed to write the net ionic equations for. Okay, so first we have to fill in their physical states. So for this first one, NaCl is aqueous because it has an alkali metal. So that's AQ, and this one's solid. And then you can work through making the net ionic equation and the complete ionic equation and the net ionic equation, or you can skip straight to that net ionic equation using a little shortcut if you've learned that. And when you get to that net ionic equation, you're going to end up with Cu2 plus aqueous plus 2OH minus aqueous, arrow CuOH2 solid. So this chunk right here will be after the arrow with a little s in parentheses, okay? Before the arrow will be the ions that make that chunk. So a copper ion, Cu2+, aqueous, and 2 hydroxide ions, these two right here, 2 hydroxide ions, aqueous, combined to form copper hydroxide solid. The spectators are the sodium and the chloride, because on both sides of the equation, they are part of an aqueous compound. For this one, when we're looking for our aqueous product, okay, nitrates are aqueous, acids are aqueous. So this is aqueous. This one becomes our solid. So the net ionic equation, when you get to that net ionic equation, you're going to have 3 barium ions, so 3 Ba2+ ions, aqueous, plus 2 PO4 3- ions, aqueous, so 2 phosphates, create this substance solid, okay? It doesn't matter if you put the 3 bariums before the phosphate or after the phosphates, but you'll have 3 barium ions and 2 phosphate ions, both aqueous, will react to form this substance, barium phosphate, which is a solid. Your spectators are hydrogen, because hydrogen is aqueous on both sides, and nitrate, because nitrate is aqueous on both sides. Okay. There will only be 2 predicting products on your quiz, so don't panic when you see all of these examples. These are just examples. We want to make sure you know what you're looking at. So here, this is a single replacement. We're going to classify. Predict the products. Iron's going to kick hydrogen out, so H2 gas. And then iron with sulfate, we're using iron 3, so it'll be Fe2SO4 3, and that is going to be aqueous. Okay. Balancing that one, sorry, we're going to end up with a 2 in front of iron, a 3 in front of H2SO4, and a 3 in front of hydrogen in order to get that one balanced. Part B, we have another single replacement. So silver gets kicked out by itself. Lithium nitrate, LiNO3. The silver would be solid, the lithium nitrate aqueous. And that one will already be balanced. Part C, a combustion. We're going to get CO2 and H2O, both gases. And then we have to balance the whole thing. And when we end up balancing it, we'll end up with a 2 in front of our C2H6, 7 in front of oxygen, 4 CO2s, 6 H2Os. Classic combustion. All right, D, double replacement. Potassium's positive. Phosphate has a -3 charge. So when I put those two together, my formula is K3PO4. And that will be aqueous because potassium is an alkali metal. Hydrogen is a +1. Hydroxide is a -1. So I put those together, I get HOH. But hopefully we recognize that that is H2O, and it'll be a liquid. To balance it, you're going to end up with a 3 in front of KOH and a 3 in front of the water compound on the product side. Part E, aluminum and oxygen, they're going to combine. That's a combination, a synthesis reaction. Think about their charges. When they become part of a compound, aluminum is a +3, oxide is a -2. So we're going to get Al2O3, and it's by itself as a compound, metal oxide, it's a solid. Part F, again, combination or synthesis, magnesium and oxygen. Magnesium becomes a +2, oxide is a -2, so MgO, they already balance each other, and that one will also be a solid. Oh, for balancing on part E, you'll end up with a 4 in front of aluminum, 3 in front of oxygen, and a 2 in front of aluminum oxide. Balancing on part F, you'll end up with 2 magnesiums and 2 magnesium oxides. G is a combustion, CO2 and H2O, both gases, and balancing will end up with a 3 in front of oxygen, 2 in front of CO2, 3 in front of water. And the last one is a synthesis reaction or combination. And again, think about charges. Na is a +1 when it becomes part of a compound. Br is a -1 when it becomes part of a compound. So they balance. So NaBr, solid because it's by itself on that side of the arrow. And to balance, we'll end up with a 2 in front of Na and a 2 in front of NaBr. Again, on your quiz, there's only going to be 2 that you have to predict the products for. 10, how can you tell if a single replacement will occur? Remember, you have to use your periodic table. We do have an activity series right here. The only way your single replacement will occur is if the single element is higher on the activity series than whatever it's trying to replace. So if we go back to this one, part A, iron is above hydrogen on this activity series. So because iron is higher than hydrogen, it is more reactive. It will steal hydrogen's partner and become part of a compound.
Marshall, please come to the main office. Nevaeh Marshall, please come to the main office.
If we wanted to give an example of something that will not occur, we could do the opposite. We could say hydrogen plus iron sulfate, iron 3 sulfate, okay? The opposite direction won't occur because hydrogen is not more reactive than iron, so it will not replace iron. Net ionic equations for A and B. Well, we've got iron. Sulfuric acid creates hydrogen and iron 3 sulfate. Okay, in a single replacement reaction, there's only one spectator. And in this case, it's going to be sulfate. Sulfate is aqueous here, and it's part of the aqueous compound on the other side. So sulfate is your spectator. And you're going to end up with 2, when you write 9A, 2 FEs, solid, no charge, plus 6 H plus aqueous, so 6 hydrogen ions. We got solid iron and hydrogen ions, react to form 2 Fe3 plus ions, aqueous, and 3 H2 molecules, which are a gas because it's diatomic, okay? All right, on part B of number 9, nitrate is part of the aqueous over here, and over here, when you write lithium nitrate, nitrate is also aqueous. So the nitrate is what cancels. It is not changing this reaction. So your net ionic equation for this one, you'll have Ag with a positive charge, aqueous, plus solid lithium, just like this, no charge. Other side of the arrow, you're going to have solid silver and lithium ions, Li plus aqueous. And that one is just one of everything. A silver aqueous ion plus solid lithium gives us solid silver, no charge, and a lithium ion plus 1 aqueous. Okay, spectator nitrate. So again, on our quiz, you are going to have the option to do a net ionic for a double replacement or for a single replacement. We will only grade 1, and it'll be the first one if you do both of them. So if you do both of them and you want us to grade the second one, make sure you circle it so that we know which one you want us to grade. Okay, that is the end of our quiz tips. I hope you guys are studying and I hope you're ready, and we will see you in class. Good luck.